None? No question? Were you guys there already?
Pwede na po, sir.
Okay. So wala talaga ang katanungan. So this is strange. So this is only my first time encountering this batch of your guys na uh, walang question. I mean, meron naman yung question pero sobrang konti. I mean, parang alam nyo na kagad. Nan talaga. Take note, we now only have 1 week. Okay, just this week. And then after that, final exam already. So there's no really a question. Okay. So I think wala talaga. Anyway, okay. So let us continue now our discussion. So the next one here is use of exit 2. So one thing that you may notice is we have the same syntax in here when it comes to do while, for x, and so on and so forth. It's just that we have an additional code in here wherein after the condition, if x is equal to 5, then exit do. Okay, and one more thing is the message box is on the above. Okay, it's not on before the increment value. Okay, so in here we have an additional one, which is then exit do, wherein once it reach the value of 5, then it will exit the application, or it will stop looping itself. So as you guys can see right here, we have a value wherein initially is 1, and then it will only stop, okay, once it reached the value 10. However, we have another condition in here wherein if x is already equal to 5, then it will exit the loop. Okay, so just take note that in here, in do while loop, we have exit loop. Okay, and then for the while loop, we have exit while. Both of those exit function have the same results, just that the syntax is different. Okay, for the do while, we have exit loop, and then for the while, we have exit while. Okay, and then for the for, we have exit for. Okay, so basically all of them, or those three, have the same functionalities. It's just that the syntax were different. So if I will show to you guys the result of this one, so let's do that one. So let's name this one exit while. So we need a button only, since our output will be shown on the message box. So let's change the font size of this one into 14 and name this one into calculate. Okay, double click for you to see the coding area, and then just paste the code in here. And as you guys can see, we're having an error since we haven't declared any variables, and we're using variable x. So we have to declare that variable x. Okay, remove that error. Okay, so in here we have initial value 1, then it will only end at 10, and it will show the result on message box. So you will see right here, once I click calculate, it will give me the value of 1 initially. Next one is 2, of course, since it's incrementing by 1. Okay, 3, 4, and then 5. So in here, it already reached the value of 5. So in here, we have another condition wherein if x is equal to 5, then exit while. So if I click OK, then it will stop looping already. Okay, since we have this function. Okay, wherein it will force the loop to be closed once it reaches this value. All right, so yeah, that's the function of this exit while. So if you guys are going to, oops. So the one that we did is exit while, okay? let's also do that one on the exit loop. So this will also give you the same result. So calculate 1, 2, 3, 4, 5. So if I click OK once more, then it will close the looping. That's very good. Since we have this function, then exit to, or this condition, and then this function. And then for the last one, so of course, this will also give you the same result. Okay, it's just that we have a different approach here when it comes to loopings. We have for and next. Okay. So we have values 1 to 10, but then again, we have this condition. Once it reaches the value of 5, it will exit the looping. So 1, 2, 3, 4, and then 5. So if I click OK once more, then it will exit the loop. So yeah, that is just another function wherein with the use of exit for, exit while, and then exit loop. Okay, and the next one here is supposedly another assignment wherein you guys will write a program that outputs some of the following using while looping statements. So let me just show to you guys the number one. Assignment loop. Right. So let me just give you the output. So we have a result here of 5,050, wherein we get the summation values from 1 to 100. Okay. So we basically just added everything from 1 to 100 and then get the result of get a result of what 5,050. So if we are going to search this one on the internet, just to prove that the summation of 1 to 100 is 5,050. So what is the sum of 1 through 100? So you will see right here that you will get 5,050, which is the same with this one. Okay. So how did I do that one? So it's actually very simple. So just declare two variable, which is the sum or the total amount of that value 1 to 100, let's say. And then we have here a counter. Okay, so CTR is the counter, which is from 1 to 100. So we have initial value, and then it will only stop once it reaches the value of 100. So we're using do while loop in here. So in here, uh, initially we have 1 only since the value of counter is 1. So we have 0, 0 for sum. So since our starting is 1, so the value of sum is 1 for now. And then, of course, it will loop. Okay, it will add another 1 for the counter. So the value of now of counter here is 2. So the previous value is 1. So 1 plus 2 is equal to 3. And then the next one is 3. So 3 plus 3 is 6. What? Yeah, it will keep on doing that one until it reach the value of 100. So yeah, once you've got the result, you will get 5,050. Right. So I hope that you guys were able to follow the the format, or how did we keep on adding the previous value to the new value. Okay, so in here it's just keep on incrementing by 1. Okay, and then whatever is the last value, okay, will be saved into our variables. Okay, so for the next one, so we have 1 to 100, but I in here is divisible by 2, wherein we'll start with 2 and then followed by 4, 6 up to 100. So basically, we're only adding the even numbers. Okay, 2, 4, 6, 8, 10 up to 100. So in here, it's actually super easy. Just change this one as a starting by 2. And instead of plus 1 only, okay, we'll change this one plus 2. Okay, so it will increment by 2 until it will reach the value of 100. So in here, if you will get the even summation from 2 to 100, okay, it will give you 2, 5, 50. So yeah, that's it for the number 2. Super easy. And then for the letter C or number 3, we have 1 squared, 2 squared plus 3 squared, and so on and so forth. So in here, this changes 1 from 1 to 10. And for the sum, we have here sum is equal to CTR times squared. Oops, it's incrementing by 1. Right? Oops, I forgot to put a parenthesis. So there you go. So 1 squared up to 10 squared will give you a result of 110. Oops, is it correct? 1 squared, 2 squared. Because 10 squared is 100. And 9 squared was supposedly 81. All right, so our calculation was incorrect. So let me just recheck this one. Counter times 2. Sum. Not times 2. Raised to 2. My bad. That is why. So we'll get 200 something or 300 something. Okay, there you go. So we have 385. You'll get the summation of 1 squared up to 10 squared. All right. So yeah, that's it for letter C. And then for the last one, okay, just change this one into this formula. So I'll not show this one to you guys anymore. So I'll leave this one as your uh, practice, or we call this one homework practice, but it's not recorded. Something like that. Anyway, so are we clear regarding with this assignment?
Yes, sir.
Yes, sir.
All right. So just basically change the formula, okay, and then you will get the correct answer. Right? Yeah, very good. Okay, so for the exercise number 9, so it says here, make a program that computes the distance a body falls in feet per second for the first 5 seconds of free fall as given by the equation. So we have this equation for the distance, wherein S is equal to 1 half AT squared, wherein A is the acceleration, and by default, we have a value of 32 feet per second squared. Okay, so that's the standard acceleration that is computed by mathematician or scientist. And then we have here a time of 5 seconds, okay, squared. So that's the formula on how you will get this distance. So in here, we have uh, 2 components only. We have the button and then the data grid view, and then the given solution for this one. So in my case, I have already created this one, exercise number 9. Exercise number 9. All right. So let me just show to you guys the result. So if I click calculate, it will give me a second from 1 to 5. So for the first second, it already traveled a distance in feet by 16. Okay, 16 feet in total. For the 2 seconds, it already traveled 64 feet. For 3 seconds, a total of 144 feet. Up to 5, which it already travels at a total of 400 feet. All right. So how did I do that one? So I just simply copied this code in here, wherein, so this one is basically the same with what we have on the past examples. So we have the titles. Okay, so again, don't forget the data grid D1, and then of course we have declared 2 variables. So TYM for the time, okay, for the T, and then DIST or distance for the distance. Okay. So we have here the title or the header. Okay, so this is your first column header, and then the second column, which is distance. Okay, and then their values below that title. Okay, and then of course we've started with 1 second, and then it will only stop once it reach 5 seconds. Of course, it's incrementing by 1. And then the formula for distance. So we already have the values for time. So it's 1 to 5. And then your equivalent values in distance. Okay. So basically, just put that formula. 1/2 times a times t squared. You have 1/2 times a, which is 32 by default, the acceleration. And then multiplied by time raised to 2. Okay. And of course, we'll show them, okay, on our data grid view. So the first one is the time, okay, and then we have here the distance wherein we have formatted whatever is the result of this one into F. So F means fixed, wherein it will only get 2 decimals, okay, and then yeah, that's it. So the time and then the distance. So as a result, you will have this one. So first 5 seconds, and then uh, the result in distance with a fixed value or with the first 2 decimals. Okay, that is why you will see right here 16.00, 64.00, etc., etc. Getting the first 2 decimals. All right, so yeah, that's it for the exercise number 9. So are we clear so far regarding with this one?
Yes, sir.
Okay. Anyway, you can do this one on your own. Okay, so again, uh, every time that we're having an exercise, you guys must do that one on your Visual Basic so that you can enhance your familiarity, okay, on how did we came up with these results, where is the formula, etc., etc. All right. So moving on, we have here exercise number 10, wherein the x and y coordinates as function of time p of a projectile fired with an initial velocity v at an angle theta, okay, with respect to the ground is given by this formula. So for the x, okay, coordinate, we have this formula. V is velocity multiplied by time multiplied by cosine theta or the angle. Okay. And then y coordinate is equal to this formula wherein velocity times time times sine theta minus 1/2 gt squared. So g right here, where is g? Okay. So we'll know what is this g later on. For now, using this formulas, write code that allows the user to input for the initial velocity, okay, wherein we have an initial velocity of 350 meter per second at an angle, let's say 285 degrees. So this is our initial inputs for velocity and the angle. So display a table of x, okay, which wherein our x is the distance traveled and the y is the height values for a projectile fired at a time of interval 0 to the total time of flight, that is t is equal to 2 times v times sine times theta divided by g. Okay, so this is our, wait, okay, this is our time. Okay, so this is the computation for the time. Okay, we have an interval value of 0 seconds with the increment of 1/2 second. This one is quite confusing. Anyway, where is our g? Gt squared. So remember to convert to radian measure. Anyway, so we'll be able to find that one out on our solution itself. So here's the uh, uh, official output when we have 350 initial input velocity and then 25 degrees for the angle. And then for the time of flight, so we have here 30.17 and it's incrementing by 0.5. So it started with 0 and incrementing by 0.5 and then their equivalent values in distance and height. All right. All right, here. So we have a constant value of G. Okay, so I think this is the force, 9.82. I think not force, gravity. Okay. If I'm not mistaken, this is the gravity, which is 9.8665 or in that for 2 decimals, we are having a 9.81 value in here. So yeah, as far as I can remember, this one was taught in P62 or P61, wherein G is a 9.81. Anyway, so we have this coding here for this given result. So all we need to do is copy this one for now, and then let's discuss the things that we have in here one by one later on. So let's create a new project and name this one exercise number 10. All right, so first we need 3 text box and then 4 labels, and then 1 button and then 1 integrity. 3 text box, 4 label, and 1 button and integrate view. Okay, let me just change the sizes of this one. 8 to 30. All right, so the first one is projectile motion. So first, second, third, and fourth one, and then another text box in here. So I'm just simply copy pasting the components that we have in here and change this one into projectile motion. Projectile motion. So let me change the color of this one into red also. There you go, projectile motion, and then we have initial input velocity and then input launch angle. Initial input velocity and another text box initial input angle. And right here we have time of light. Then compute. Okay, we need more space right here. And of course, this is the one that we're going to program. Okay, so we have errors, all right. And we have a continuation for this one up to this slide. Oops. I see. Okay. Then I'll just paste it down here. And we're having an error here because this one by default is named data grid v1, not dg1. Okay. So let me just change this one into data grid v1. One into data grid v1. This one also. What else? And VO is declared a single. Oops, beam the okay, might assign radians. Where is this radians coming from? Let me remove this one for now, because if not, then we have to multiply this one by math.pi divided by 180 to convert this one in radians. But I'm not sure if this one is already in radians or not. And we have g here for the constant value. And right here, I'll remove this one also. This one is the D to grade V1. Okay, so let me check the result for now. We have the same result, 350, 350 and 25 and 30.17. Why do we have that result only? Wait, how many inputs do we have? Two inputs only. So the time of flight here will be solved by our solution itself. Time of flight t. Where is that t? It's incrementing by 0.5.
Declare pa sir yung zero eh. Sa T.
Because,
Zero pa rin po sir yung naka-declare.
ano yan?
Pag nag-input tayo ng time of flight sir, pero zero pa rin yung naka-declare, parang doon ata yung conflict.
No, I think because in here we only have two input. Okay, we have the text box 1 and text box 2, and then text box 1 is the velocity, and then the text box 2 is the angle. Okay, so in here the time of flight will be computed.
Hindi siya input sir.
Okay, let me just find formula for t on how did we get that t flight. So initially we have a time of 0, and then it will only stop once it reached a value of t flight. And it's incrementing by 0.5. Okay, so let me just edit this one first. We're in our sine, cosine, sine, tangent, or whatever is that should be in radian. So we have here math.pi, times math.pi divided by 180. Okay, let me just check if it's the correct format. Math.pi. So it is in our module 7. Okay, math.pi divided by 180. All right, there you go. Okay, math.pi. All right, so let's see. We will have the same result. 350, 25. There you go. So we have to convert this one, okay, from degrees, okay, into radian. So just multiply that one by math.pi divided by 180. Okay. So I think in here, so we've started with 0, okay, as our initial time, and then of course we have initial distance, which is equal to 0, and 0 for height also. And as it travels, okay, So of course, it will reach a peak value, okay, a peak value of 1,000. Where is that? At 15 seconds. Yeah, 15 seconds, it will reach a height, okay, a total of 1,115.50. And if you're going to take a look on this one, so it's now decrementing, meaning it's now falling. All right, it's now falling until it reach the value of 0. So it stopped at exactly 30.16 seconds or 30.17 seconds. So it has a total travel time of light from 0 to 30.17. Okay. So it will only stop, of course, once it reach uh, the ground, okay, wherein we already have 0 height in here. And then it traveled a distance of a total of 9,569.06. So I'm not sure if you guys can see this one, but it traveled a total distance of 9,569. All right. Okay, so in here, let's see what are the things that happening here. So we have declared these variables. So T for time, D for distance, H for height, and then the T flight, total time of flight, and then VO for the velocity, and then angle is for the angle. And then we have here a constant variable wherein, I think this is the gravity, which is a 9.8665. And then we have two inputs right here, which is coming from the velocity and the angle. And we have this data grid D1 column set clear, which will clear whatever is in that before it will show you the result to avoid overlapping results. And then we have here the three columns, the time, distance, and then the height. Okay, and then their corresponding values, the P, D, and H. Okay, so here's how we computed the P flight. So it's 2 times velocity times mat that sign times angle times mat that. So in here, this basically converted this degrees into radian divided by the gravity. Okay, so just go back on our worded problem here for you to be able to have this formulas for T flight. T flight right here, 2 times velocity times time times the angle divided by g, which is this one. Okay, and then the text box 3.text will be solved, or whatever is the result in here will be shown on our text box 3.text. Okay, and then we have here the formulas for the distance and then the height, wherein you will see the distance formula right here and then the height formula right here. Okay, and then it's incrementing by 0.5. All right, so